Okay, so we're going to move on to part 2. And I've made a data table for part 2, and this is just a rough sketch, but I put the different solvents, instead of the different colors, I put the different solvents in each of the rows, and I also put the distance traveled in observations in the same row, just as I did in the other charts. So, or columns rather. So, let's see how it's set up. I've already got the vegetable oil filter paper and the alcohol filter paper set up. And again, in order to make these, I just cut the big filter paper in half. So the way that I folded them was, I said, well, it doesn't need to touch the bottom of the well, but it needs to be close to the bottom, and that ended up being about 1 centimeter. So I also labeled these with pencil. The pencil is not going to affect the experiment at all, so I'll label this one water. So again, I just took the filter paper and I folded it and made sure that it wasn't touching the bottom of the well, but it was really close. And you're going to need 3 separate pipettes for this experiment so you don't cross-contaminate your solvents. And you may even want to label the pipettes as I have labeled them to make sure that I don't get them mixed up. So, just read your instructions here. It says, now again, we did modify this experiment. Instead of doing 12 of these with 3 different colors, we're only doing 1 color, and we're only doing 3, the vegetable oil, the alcohol, and the water. And that's to make it a little bit shorter for you guys and a little simpler. So the color that I chose to use is the green because I thought it had the best separation of the 3 colors that we used in the first experiment. And the directions say, under number 4 on part 2, to place, using the black marker, well, we're doing the green marker. So using the green marker, place a dot approximately 0.5 centimeters in diameter in the middle of the crease of the filter paper strips. If you look in the photo, the dots aren't on the crease. They're between the bottom and the crease. So it's like in the middle of this, not in the middle of the crease up there. But when you make these dots, you've got to make sure that the dot itself doesn't have contact with the solvent in the well. It has to be above, so that what is touching is only the solvent down here at the bottom, but the solvent wicks up and then begins to touch it. So I'm going to make my dots in the middle of the creases. And I'm doing it over here so I don't get any permanent marker on the table, because I've already done that. Okay, and let's fill up our pipette, or our wells, with each substance. And I have my vegetable oil here, and I just got that out of my pantry. And then water, of course, from the sink. And then the rest of the denatured alcohol from the first part of the experiment. So I'm going to start with the water. This water, I'm going to fill up half of the pipette. There's going to be about 1.5 milliliters, because this is a 3 milliliter pipette. And transfer it into the well. That looks like a healthy amount. Good. Then the alcohol, labeled A for alcohol. Again, about a mil and a half to the middle well. Right there. And a mil and a half. Oh, these are 1 milliliter pipettes that they have. Okay. Okay, so I was using 3 milliliter pipettes. You guys have, I believe you have 1 milliliter pipettes. So in order to stay consistent, I'm going to also put a mil and a half in the vegetable oil well here. And I actually think a mil and a half is a good amount. So don't do half of the pipette like it says in the directions. Let's go ahead and do a mil and a half. Alright, I'm going to make sure that each one of these filter papers that I have labeled goes into the appropriate well. So this one over here was the water. The middle one is the alcohol, and this one was the vegetable oil. Again, try to make this so that it's pointing straight down. I'll put the water in, alcohol in, and finally the vegetable oil. And let's come back in about 20 minutes to view the results. Okay, so I've had these strips in the wells for about 13 minutes now. And what we see here is that the water has moved the furthest on the paper, if you can see that. See the solvent line?
It was better before you touched it.
My bad. And then the alcohol here, the solvent line is right there. But this actually took the marker with it, whereas the water, it stayed in the same place. So that's interesting. I'm interested to know why the water didn't move the marker and the alcohol did, and the differences between these two solvents. Also, for the vegetable oil, it didn't move at all. So in our data table that I made, we're going to not measure the distance for this one, not measure the distance that the marker traveled, but measure the distance that the solvent traveled. So measure it from the middle of the dot, just to make it consistent. Okay, so for water, I would say that it moved 5.13 centimeters from the center of the dot. So I'm going to write that in my chart. I said 5.13 centimeters. And then the observation I'm going to write down for this is that solvent, the water, or this is actually the solvent, but it's also the mobile phase, keyword, moved the furthest. Did I say furthest? Furthest. Move the most. Move the most. but didn't move the marker. In layman's terms, anyway. So, record the rest of your observations and the distance that each solvent traveled. And then from the data, you should be able to answer the analysis questions on page 5.